Alrighty, welcome back to some fun maths. We are looking at multiplicative, inverse, and how to use that to solve matrix equations. What you do need to know for this particular exercise is if we are referring to matrix A and we're talking about particular elements and we're working out particular things with the inverse, these elements in these positions are labelled A, B, C, and D, and they are used for these different calculations. Things you need to know. When you've got one matrix and it's multiplied by its multiplicative inverse, what's going to happen is you're going to end up with your identity matrix. That is denoted with a capital I. So it's useful to know matrix multiplied by its inverse is going to be the identity matrix. Cool. Next thing is actually the symbols that we are going to use to represent the inverse of a matrix. In this particular case, you're going to end up with like an A with a power of -1. If you see that, it just means we're finding the inverse of that matrix. Another thing to note is that the matrix must be a square matrix. 2 by 2, 3 by 3, 4 by 4, etc. So that you can find the inverse. If it's not square, you're not going to be able to do that. For the sake of this particular maths course as well, we're only going to be working out the inverse of a 2 by 2 matrix by hand. If they ever asked you to do inverses of larger matrices than that, you would be using your class calculator for that. Another thing to note is multiplicative inverses only exist for regular matrices, and by that I mean if the determinant of the matrix is not 0. So on the other hand, if you do get a matrix that has a determinant of 0, that's going to be called a singular matrix, and it has no inverse. So when we go to do these questions, as part of the process you have to calculate the determinant. We'll have a chat about that. If you calculate the determinant and it comes out to being 0, then there's no point going on any further to try and find the inverse of that matrix. It can't be done. So here are the steps that we need to use to find the inverse of a 2 by 2 matrix. First thing we need to do is find what's called the determinant of the matrix. Whether they ask you to work out the determinant of the matrix, or whether you see a little det with a capital A, or the A with little bars around it, they are all different ways we can say, hey, what is the determinant of the matrix? Now, in order to calculate the determinant of the matrix, we use this formula that is here. So it says the determinant of A is equal to the value A multiplied by D, take away the value of B, take away C. Now that was from these positions earlier that I spoke about up the top here. So you get the values of A, B, C, and D from their positions in the 2 by 2 matrix, and we can then run that calculation. So that's the first step. After that, we need to swap the elements of the main diagonal. So again, we said the main diagonal starts at the top left and goes down to the bottom right. So we're swapping the A and D values around as such there. The last thing that we do as part of step number 2 is we're going to multiply the other diagonals by -1. So whatever the values were on this diagonal, this way, you're going to change the sign. So ultimately, if they were positive values to start off with, they're going to become negative values when you multiply by -1. If they were negative values and you multiply by -1, they're going to become positive. So essentially, on this diagonal here, the values, the sign is going to change of those ones. Last but not least, the final step of working out the determinant, or the inverse by using the determinant, is to multiply the matrix that we just worked out by that inverse of the determinant. So you got the inverse of matrix A is 1 over the determinant, and we can see there the determinant is just that AD take away BC, and that is then going to be multiplied by the part 2 that we looked at, where we swapped the elements around and also multiplied the the other elements by -1. We'll have a look at an example and it'll become a bit clearer. One of the other things that we want to talk about is how this could be used for solving equations. So what you do need to know, it says the order that we multiply matrices is important, and we must be careful of the position of the inverse. So what you do need to remember is that if you multiply matrix A by matrix X, it's different than multiplying matrix X by matrix A. So let's look here. If you've got A x equals B, then they're saying here that when you rearrange things, x is going to be equal to the inverse of A multiplied by B. So the reason for that is, as we saw initially, a matrix X here is getting pre-multiplied by matrix A. So if we think about how we can get rid of or move things around in equations, to get rid of this A from the left hand side, you would have to obviously multiply this side by the inverse of A, which would become the identity matrix. And we know anything by the identity matrix is just itself, multiplied by the identity matrix is itself. Now, because we pre-multiplied this side by the inverse of A, you have to pre-multiply the right hand side by the inverse of A. So it needs to come before this B here. On the other hand, if you had this one here, x A equals B, the A is the thing that's multiplied second, so it's post-multiplied. So obviously here you're going to be taking the inverse of A after the x. Because you took it after the x here, we're going to do it after the B over this side here, as such. So the order is important in which we do these things. Alrighty, let's have a look here at some examples. So they can ask you to calculate the determinants for the following matrices. So matrix A here, we've got those items 3, 4, 2 and negative 3. You need to know to calculate the determinant of A. The formula, as we said before, it's A multiplied by D, take away B times C. So let's actually work this out. Determinant of A is equal to A times D, so 3 times negative 3, take away B times C, so B was 4, C was 2. We can run that calculation now and we get negative 17. Next matrix we're going to find the determinant of. This is matrix B, so we're going to find the determinant of B. Again, it's A times D, so 6 times 2. Take away B times C, 3 times 2. 12 take away 6 is 6. Last one we want to find out the determinant of C. Okay, it's A times D, so 4 times 6. Take away 8 times 3. Oops, times 3. In this particular case, it is equal to 0. Cool. Next one, it says here, find the inverse of this particular matrix here. So let's go through the process. First thing we need to do is work out the determinant of that matrix. So let's work out the determinant of A. A times D, so 3 times 4. Take away 5 times 2. We get the determinant in this case is 2. Now, as we said a little bit earlier, if you are working out the inverse, it is 1 over the determinant. So 1 over AD take away BC multiplied by the matrix where we swap things in the diagonal. So the A and D swap positions, they've swapped, and these values on the other diagonal become the negative. So let's plug in the values that we know. It's going to be 1 over the determinant. We just worked out what the determinant was over here. So it's going to be 1 over 2, and that's going to be multiplied by this matrix here. The A and D values are going to swap around. So A was 3, it's going to go down to this position. D was 4, it's going to go up to here. And we're going to swap the signs of the B and C values. So they were both positives, so swapping the signs, that's going to now become a -5, and that was a positive, that's going to become a -2. We have now worked out the inverse of A. Alright, last few that I want to talk about. We've got some matrices here. We've got matrix A and matrix B. It's saying in this particular case, solve for the unknown matrix X. So, first of all, it's saying here we've got AX equals B. Now, as we spoke about before, if we want to find out what X is, we need to get rid of matrix A from this left-hand side. So getting rid of it, we're going to have to, before the X, we're going to have to multiply this side by the inverse of A. And because we did it like pre this X here, it was a pre-multiplication, it has to be done pre on the right-hand side. So it's going to be the inverse of A over here, multiplied by B. Obviously, the inverse of A multiplied by A is the identity matrix. When the identity matrix is multiplied by X, it's just going to be X. On the right-hand side, we've got the inverse of A multiplied by B. So now we actually need to work out the inverse of A, and then we'll be able to multiply that by B, and that will tell us what X is. So let's work out the inverse of A. First part of working out the inverse is to work out the determinant. That's A times D, take away B times C. In this particular case, you've got 2 times 3. Take away 5 times -1, and you're going to have 11 as the determinant. Obviously, writing out the determinant, the inverse, it's going to be 1 over the determinant, which is AD take away BC. I'm just writing out the formula here, multiplied by those that swap around. That becomes D, that becomes A, and the signs swap around on these. Let's fill out the values we know. So it's going to be 1 over the determinant, which we worked out up here. It's 1 over 11. The A and D values will swap around, and the signs are going to swap on the alternate diagonal. So that was +5, it's going to become -5. This was -1, it becomes +1. Alrighty, we'll go up here now, we'll go over here. So we're going to have X is equal to the inverse of A multiplied by B. So the inverse of A was 1 over 11. We had these numbers here in the matrix. And that's going to be multiplied by matrix B. So let's write out matrix B. That's 16, that's a 7, that's -3, and that's 3. We can multiply these two matrices together. This 1 over 11 will still stay out the front. Doing the matrix multiplication, you end up with 33, -44, 22, and 11. From there, multiplying by 1 over 11 is the same as dividing by 11. 33 divided by 11 is 3. -44 divided by 11 is -4. This one divided by 11 is 2. 11 divided by 11 is 1. So we have the answer there for that one. x is equal to this matrix here. Alright, it's getting a little bit cramped, but we'll deal with it. Alright, in this particular case, you've got ax equals 13 and you've got negative 1. Again, to find out what x is, we need to get rid of this a here, so we're going to pre-multiply that side by the inverse of a. That's going to get rid of that because it's going to be the identity matrix. Now, because we have pre-multiplied this side by the inverse of a, you're going to have to pre-multiply this side by the inverse of a. So ultimately you'll end up with x on the left hand side is equal to the inverse of a multiplied by this matrix here. Again, we can work out what the inverse of a is. We worked it out previously over on this example. So we can just use this down here. The inverse of a was 1 over 11, 3, negative 5, 1 and 2. That's multiplied by this matrix here, 13 and negative 1. We can multiply these two matrices together. It comes out to being 44 and 11. Again, as we said, multiplying by 1 over 11 is the same as dividing by 11. 44 divided by 11 is 4, 11 divided by 11 is 1. We have found out what x is equal to. Thank you very much for listening. I hope you enjoy your day. Bye for now.